Please welcome Michel Twadzik, Ruhr University, Bochum.
My name is Michel Twadzik and I am project coordinator in the World Factory Startup Center at the Ruhr University in Bochum. We are thrilled to nominate xemX as a Science Breakthrough of the Year 2024 and that they are part of the top 25 teams. We nominated xemX because they find a groundbreaking solution how critical electrifying chemical processes can be turned into a sustainable chemical industry. xemX employs a three-step approach to develop high-performance materials for electrolysis. Initially, they use a screening technology to identify promising materials, followed by producing and testing samples and prototypes. Finally, xemX validate these materials under industrial conditions and integrate them into a manufacturing process.
Breaking the wall to new materials in green chemistry. Sven Maihöfer, xemX.
I will explain our startup a little bit easier here. Our customers are the chemical industry, and they are reinventing themselves. They are using electrification of their chemical processes to become carbon neutral. However, significant barriers still exist. The current materials were made for the past, but electrochemical processes will need materials which will keep up with the future and power a cleaner tomorrow. For example, hydrogen is a hot topic in the green energy transition, and the demand of green hydrogen is rapidly growing worldwide. But why is hydrogen not taking off? One reason is that the materials used in electrolyzers, they just don't last long enough. So hydrogen producers are constantly worrying about shutting down their hydrogen production and replacing the old wasted material. So there are major material innovations which can lead to scientific breakthrough, but there is a catch. Right now, on the one hand, we only use those 12 elements in the middle of the periodic table to find and create new materials. This is a very short and small search space to find innovative materials. On the other hand, when we're using the full potential of the entire periodic table, this can be overwhelming and a daunting task, like finding a needle in a haystack. So our customers lose precious time to find a suitable material for their application. And the key competence of our customers is to develop chemical processes. Let them focus on chemical production and let us break down this wall and enable our customers to lead to CO2 neutral future with advanced materials. We developed a data-driven and machine learning optimized technology to identify the best materials out of millions of possible combinations and deliver high performance and customer-tailored material solutions. We created the worldwide biggest material database for electrochemical properties, and we replace 600 years of traditional research. What sets us apart from the competition is that we understand the struggle of our customers to find a suitable material which will survive in a real industrial setting and not only survive in a computer simulation. Why guessing a material composition when you can know it? We don't rely at xemX on simulations. We will use real data and real experiments, so advanced material development, which will lead to a CO2 neutral future. We are currently gaining traction, and we started 6 months ago to sell our first services and created a 6-figure revenue stream with our first pilot scale production. And now we need to scale and develop more high-performance materials for the future and getting more customers worldwide. So probably we will need around 2.5 million euros to start the pilot scale production in the future. Right now we are focusing on hydrogen. This is our beachhead market. But we will develop high-performance materials beyond hydrogen. It will be step-by-step conquering new markets in electrochemistry. Now hydrogen, then ammoniac, methane, and CO2. We are a team of dedicated engineers who love material innovations. Lars is our creative head. He's combining material science, electrochemistry, and AI. I'm the business developer, and I have a material science background. And we have 2 professors on board who combine over half a century of experience in developing materials in the academic field, and they support us a lot. So we love materials. If you have a material challenge, an exciting material challenge, let me know, and let's steer down the walls in electrochemistry to help lead the future to a CO2 neutral future with advanced materials. Thank you.
Okay. Very good. I think you should get a bonus point to be not unimpressed because your nomination institute could not tell us properly why you're so great, but we saw it. So it's
Thank you.
Yes.
Merci.
Yes, exactly. Oh, you want to continue?
No.
Okay. Good. We have one question here with Rasmus to start with. Thank you.
Yeah, 2 questions. Can you talk a bit more about your data collection setup? And secondly, like, how do you do the value capture? Like, are these chemical companies pay you well enough for it, or should you maybe just disrupt them directly? Like, how do you think about this?
Yeah, so we have in our lab, that's why my co-founder is right now in the lab doing more experiments. We can test 2,000 compositions per week. So imagine you have like a silicon wafer, and we have 450 points with nano layers with our different compositions. Like a grading system, we use platinum, gold, nickel, all the elements our customers want, and then spray them on a wafer, and then test them with our robots, and create a kind of a heat map with the best materials. And the customers, so some customers understand how much we accelerate their research, so they are willing to actually pay quite a lot. We did not expect that, but we want to become from a service provider to a delivery or the manufacturer of materials and deliver them to our companies too. So this will be the future.
Does it answer your question? Yes? Okay. Iris?
Thanks. Actually, I have a follow-up question on that, I guess. So the wafer that you're describing with the dots on it sounds a bit like a model system. So I was wondering how representative the results then are for real-life electrochemical cells.
Oh, that's a good question. So we started in academia, right? We are researchers, and this was our biggest breakthrough. We had to show that we can transfer the results from a wafer to real industrial settings. And this was what we did the last 4 years in academia. Then we realized, ooh, this works. We had promising results, talked to customers in industry, and they were impressed. And then we said, let's found a GmbH or the company. Yeah.
Okay. You know, it doesn't impress the jury if you say it's a good question. Huh? It's like when I say I would give you a bonus point, I have no influence.
Okay.
Okay, next question. No one?
This?
Yes.
Okay.
Here. Okay. No, okay, I will come back to you
if I
first time.
understand what you're doing correctly, this is sort of dial a molecule and testing what you're getting out the other end.
Dial a molecule?
Yeah. You're using your data to create a molecule.
Yeah, we create...
So that's not new.
Yeah.
So what is new about what you're doing?
So what we do is a normal process of getting a new catalyst, for example, will take sometimes months and years, and we can create different compositions within weeks. So when you have a specific problem and you have a new alkaline water electrolysis technology and you're normally using copper and nickel, but you want maybe higher performance or lower price, we will mix them with different materials and get in with you within 3 months we have the first results. So I would say we are the fastest company doing those material testing.
Okay, we have a lot of questions. So here is a very quick one, second one, please.
If you have an example of some of these industrial validation tests that you've done, if you could comment on the results of some of these.
Yeah, so the results, I can't tell you the over potential, etc., because we signed NDAs, because they are very customer-tailored products. But we have companies from the Middle East, New Zealand, and they all are, let's say, startups doing their own technologies and need materials for accelerating their technology, right? So we are taking a lot of work from them. And so it's constantly, we are creating new samples, they test it, they give us feedback, we do more experiments.
Okay, 25 seconds. Very short question, very short answer. Anyone? No? Good, then we're good. That's fine.
Thank you so much.
Thank you very much.